Welcome students to online classes of mathematics for class 8. In this video we're going to study chapter number 12, which is powers and exponents of NCERT textbook. Here we're looking at the exercise 12.2. This one is the session number 2 for this particular chapter. Myself Deepak Kodam, DGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The chapter number 12, exponents and powers, divided into total 4 subtopics, out of which we have already covered the first 3 subtopics in the previous session. Okay, and here we'll be looking at the particularly use of the exponent to express small numbers in standard form. Okay, and let's do some example based on this, then we'll move to the exercise 12.2. Okay, so we are using the use of exponent to express a small and large number in standard form. Okay, so we are given this number, which is a very large number. Now we are going to write this in the form, in the standard form. Okay, as we are asked to convert this number in the standard form, which means we'll write them into the form of 10 raised to power. Okay, so when you are given a number like this, you we can't see a decimal here. Okay, so there is no decimal, so we assume that decimal to be at the end here. Okay, so when there is no decimal given in the question, we assume that decimal to be at the right end. Okay, now in order to convert this into decimal form, what we are going to do is we're going to bring this decimal right after the first digit here. Okay, we're going to bring the decimal here by moving the certain places. Let's count the number of places. So from here we're starting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means we need to shift this decimal to 11 places. Okay, so what we are doing here is we are shifting the decimal from right to left. Okay, right to left. In that case, the power of exponent will be positive. Okay, so we have moved it to the 11th place, so this number will be 1.5. Okay, so we have moved the decimal from the end to right after the first digit, that is 1.5. Okay, then we will write into 10 raised to power the number of places we have moved it. So we have moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this will be plus 11. Like I said, when we shift from right to left, the sign of the power will be positive. Okay, let's understand one more example. We have this large number, this one. Again, we are not given a decimal here, so we assume the decimal to be here. Okay, and we are going to shift the decimal right after the first digit here. Okay, so let's start. Count the number of places we have to move. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and again 11. So this is 1 point. Okay, so in the previous one we have written this 1.5 and we eliminated all the 0. Okay, but here after the 1.4 we have 9 and 6 also, so we'll write those digits also. 9 and 6 will remove only the zeros. Okay, so we're not going to write these 0. Right after that we'll write 10 raised to power. So how many places we have moved? Number of places we have moved is 11. Okay, so this 1.496, 10 raised to power 11 meter. Okay, again we are moving from right and to the left side, so the power of variable exponent will be positive. Okay, now next one is, now you can see the decimal is given here. Okay, in order to convert in standard form, again we are going to shift the decimal right after the first digit. Okay, so that means how many places we have to move? We have to move from 1, 2, 3 places only. Okay, so we'll bring this decimal right after the first digit, that means 1.6 into 10 raised to power, how many places? 1, 2, 3. But when we move the decimal from left side to right side, the power of decimal will be negative. That means this should be minus 3. Okay, so when you're shifting from left to right, the power of exponent will be negative. Okay, and when you shift from right to left, the power of exponent will be positive. Okay, right to left is it's positive and the left to right is negative. Okay, similarly in the fourth one, again you can clearly see the decimal here. We're going to bring the decimal right after first digit here. Okay, let's count the number of places we have. 1, 2, 3, 4, and 5 places we have to move. So this will be 1.2. So whatever the digit after the decimal, we're going to write those digits. Okay, we ignore only the zeros, but we'll write all the numbers. So we have 1.275 into 10 raised to power. We have moved 1, 2, 3, 4, and 5 places. Okay, so again we are moving from left to right. That means this part will be minus 5. Okay, so that's how we convert the given number, which is can be a small number or large number, into standard form. In standard converting in standard form means we're going to write this in the form of 10 raised to power. Okay, and if we move from right to left, the power of exponent will be positive, or if we move from left to right, the power of exponent will be negative. Okay, now next is the use of exponents to express the small and large number in the usual form. Now the number will be given in the standard form, that is in the form of 10 raised to power, and we are going to convert them back to the usual form. Okay, rule is same. Okay, like we did in the previous one, we have this 7 into 10 raised to power 6. Since its power is positive, that means we'll write the number which is 7. Okay, assuming the decimal here, we're going to shift the decimal to the 6 places. So we'll write, okay, it is 10 raised to power 6 means we're going to write 6 zeros, 1, 2, 3, 4, 5, and 6. Okay, so the date is 7 0 0 0 0 0 0. There is no decimal here. Okay, so let's see the given number in the usual form. Okay, in similar way we have this 1.4 into 10 raised to power 9. This means we're going to shift the decimal to the 9 places toward right. Okay, that is, it will be 1. So now we have this 9 power means we already have one digit after decimal. After that we're going to write the 8 zeros. So we have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, in total after this decimal we should be having 9 digit. Okay, so after this 1 we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 digits. Okay, including that number also. Okay, now we have this 7.54 into 10 raised to power minus 4. Now you can see the exponent is a negative exponent here. Okay, so we're going to shift the decimal toward the left hand side. Okay, so we have this 7.54, and the power is 10 raised to power minus 4. Okay, so since the power is negative, we're going to shift this decimal toward the left hand side. Okay, so we have already this 754. We are going to move this decimal toward the 4 places. Okay, so it will be here, from here to 1, 2, 3, and 4. So having 1 0 here, 1 0 here, and 1 0 here, then decimal, then another 0. Okay, so since the power is minus 4, we have changed it from starting from here, 1, 2, 3, and 4. So that's the answer, that is 0.0000754. Okay, in similar way, now we have 3 into 10 raised to the power minus 5. So write this 3 here, assuming the decimal here. So we're going to move 1, 2, 3, 4, and 5. That means 1 0 here, 1 0 here, 1 0 here, and 1 0 here. Then decimal and 0. Okay, so let's count from here to 1, 2, 3, 4, and 5 places we have moved it toward the left. So the number is 0.00003. Okay, which means if exponent is positive, we shift write the zeros toward the right hand side, and when exponent is negative, we write the zeros toward left hand side. Okay, in these cases exponent is positive, so we are writing the 0 toward right hand side. Okay, in this also we're writing 0 toward right hand side. Okay, but here the negative exponent is negative, so we are writing zeros toward left hand side and left hand side. Okay, if you understood the difference, in order to convert the number into the standard form, if you are moving from right to left, the power of exponent will be positive. and if you are moving it left to right, the power of exponent will be negative. Okay. Similarly, if the exponent is positive, we'll increase the zeros toward the right hand side, and if the exponent is negative, we'll increase the zeros toward the left hand side. Okay. Now based on this, we have exercise 12.2. Now let's move to the exercise 12.2 now. Okay. Exercise 12.2 is this exercise in total have 4 questions. We're going to do all the 4 questions in this session. So let's start with the question number 1. We have express the following numbers in standard form. We are given the certain number which are in usual form. We have to convert this into the standard form. Okay. So let's start. We have the question number 1. Part 1, the first number is 0 point. Let's count the zeros. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we have 8 and 5. Okay, now you can see since the decimal is here, we are going to move it to at this place. Okay, so let's count the number of places we are going to shift the decimal. That is from here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and the 12. So this number will be 8.5, okay, into 10 raised to power. Like I said, we are moving from the decimal toward right hand side. So the power of exponent will be here negative. Okay, that will be how many places we have moved? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there will be minus 12. Okay. Since we are moving the decimal toward the right hand side, so the power of exponent will be negative. And let's see the next one now. We have 0 point. Let's count the number of zeros here again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's write again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we have 9, 4, 2. Okay, again clearly you can see we are having the decimal here, and we will shift it to the right after the first digit, that is 9. That is first number, not the digit. That number is 9. Okay, so let's count the number of places we are going to move this. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and again 12. Okay, so this will be 9 point. We're going to write all the numbers after the decimal, that is 4, 2, then 10 raised to power. Since again we are moving from left to right, so the power of variable exponent will be negative 12. Okay, I hope you understood the two. Let's see the third one now. We have here 6, 0, 2. Let's count the zeros now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So that's our number. Okay. In order to convert this in the standard form, we're going to write this as, we are having the decimal here at the end. Okay, and we're going to shift the decimal right after the first number. Let's count the number of places it will be shifted. That is from here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay, so this will be 6.02 10 raised to power 15. This time we are moving a decimal from right hand side toward left, so the power of exponent will be a positive number. Okay, let's create some space now. Next one is, we have 0 point. Let's count the zeros now. We have 1, 2, 3, 4, 5, 6, 7, 8 and 8, 3, 7. Okay, 1, 2, 3, 4, 5, 6, 7, 8 and 8, 3 and 7. Okay, so this will be, since we're having decimal here, we're going to shift the decimal toward the right hand side. Let's count the number of places. Okay, we are going to want to bring it here. Okay, so let's count the number of places. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this will be 8.37 10 raised to power minus 9. Again, as we are moving from left to right, it will be decimal will be exponent will be negative. Okay, or you can remember this. As you can see, we have this decimal here. This is a very small number, and we are writing the small number in the decimal form, so there will always be a negative exponent. And when you write a large number into exponent form, there will always be a positive exponent. Okay, large number means positive and small number means negative. Okay, so when you have such large number like this one, and you're asked to write this in the exponent form, the power of exponent will be positive. Okay, large number is a very big number, that means it will be in the multiples of 10. That means it will be, its exponent will have positive value. Okay, when you have very small number, that means it will be, it's a very small number that is a part of a, a number, that means its exponent will be negative. Okay, now see the last one. We have 3186 3186. Let's count the zeros now. We have 1, 2, 3, 4, 5, 6, and 7. So we have 1, 2, 3, 4, 5, 6, and 7. Okay, so we have the decimal here at the end. So let's count the number of places. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this will be 3.186 into 10 raised to power. Again, this is a very large number, so its power will be again positive. Okay, or we are also moving from left to right, so the power of exponent will be a positive number. Okay, so that's the answer of the question number one. Now moving to the next one. Here again we are given the certain number. We have to now convert these into the usual form. Okay, so let's start the answer number 2. Part 1, we have 3.02 into 10 raised to power minus 6. So we can write this number as, since the next power is minus 6, okay, so that means that number used to be a very small number. That means we will going to add the zeros onto the left hand side. Okay, so this will be, we have the decimal here, the number of power here are 6. We already have one digit here, so we are going to add the 5 zeros. Okay, okay, understand this. We have the power as 6. Since the power is minus, so we are going to add the 0 toward the left hand side. Okay, so before the decimal we have one digit, so after this 6 we have already one digit, so we are going to add the 5 zeros here. So this will be 0 point, let's write 5 0, 1 2 3 4 5, then we have this 302. Okay, so that's the answer. Similarly, second one is, we have 4.5 into 10 raised to power 4. Okay, now as you can see that 10 raised to power is plus 4, that means that number used to be a large number. Okay, that means we are going to add the 0 toward the right hand side. That means we already have one digit after decimal, so we need only, after this 4 we have already 1, so that means we are going to write the 3 more 0, so it will be 4 5. So we have one digit here already out of this 4, so we can try 3 zeros, 1, 2, and 3. So that's the answer for this one, that is 45,000. Next one, we have the number now 3 into 10 raised to power minus 8. Okay, so as we have the minus power of this 10 is, that is negative exponent, that means this number used to be a small number. Okay, so we are going to add the 0 toward the left hand side in this direction. Okay, since we already have one digit, that means after this 8 we have already one digit, so we are going to write the 7 zeros. Okay, so let's write the 0 point Let's write 7 zeros: 1, 2, 3, 4, 5, 6, and 7. Then write this 3. Okay. Why I have added 7 zeros here? Because total minus power here is 8. Out of those 8, we have already have one digit here, 3. That means we need 7 more digits. So we're going to write 7 zeros here. Okay. Next one, part 4. We have 1.10001 into 10 raised to power 9. Okay. So as I told, since the power of exponent is positive number, sorry, exponent here is positive number, that is 10 raised to power 9. That means this number used to be a large number. So that means we are going to add the 0 toward right hand side. Okay. So the power here is 9 and we already have 1, 2, 3, 4 digits after decimal. That means after this 9 we have already 4 digits. We are going to need 5 more digits, and that means we are going to add 5 zeros here. Okay. So we have 1, 0, 0, 0, 1. Okay. So we have written the 4 out of this 9. So we're going to write the other 5, that is 1, 2, 3, 4, and 5. Okay. So from here the decimal will shift to the last. So the number is 1, 0, 0, 0, 1, 0, 0, 0, 0, 0. Okay. Now moving to the next one. Next is 5.8 into 10 raised to power 12. We have 5.8 into 10 raised to power 12. Okay. Again here the exponent is a positive. That means this number is a large number. So we are going to add the zeros to our right hand side. Okay. Out of this 12 we have already have one digit here. So that means we need 11 more zeros. Okay. So we'll write 5, 8. Okay. So out of this 12, we have one digit here. So we're going to write the 11 more digits. That's it. 11 zeros. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. Last one is we have 3.61942. 3.61942 into 10 raised to power 6. Okay. Again, since the exponent is positive, let me write it again. Since exponent is positive, that means this number is a large number. Okay. So power is 6. We already have 1, 2, 3, 4, 5 digits after decimal. So we need only one more. So we'll add the 1 zeros at the end. Okay. So it will be 3, 6, 1, 9, 4, 2, and 1, 0. Okay. So that's the solution of the question number 2 of exercise 12.2. Okay. Number in the usual form. Now moving ahead to the next question. Question number 3 is express the numbers appearing in the following statement in standard form. So we are given certain statement having a number. We have to convert this number into the standard form. Okay. So let's start with the first one, that is answer number 1. Sorry, answer number 3, part 1. We have 1 micron is equals to 1 by 1000000. We have 6 zeros here. That is this 1 divided by 6 times 0 will be 1, 2, 3, 4, 5, and 6. We can write this number as 1 divided by 10 raised to power 6. Okay. So as we have 6 zeros, so we can directly write this as 1 divided by 10 raised to power 6. So when you shift this number to the numerator, it will be 10 raised to power minus 6. Okay. That's the number in the standard formula. You can write it as 1 into 10 raised to power minus 6, or you can directly just write 10 raised to power minus 6. Okay. Moving ahead to the next one, we have the charge of an electron is equals to this big number, or not big, very small number. Okay. So we have part second, charge on electron of an electron is equals to, let's count the number of 0. We have 3 plus 3 6 plus 3 9 plus 3 12 plus 3 15 plus 3 18. So 18 zeros we have here. So write 0 0.1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Then we have 1 and 6. Okay, so we can write this number as 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 1, 6 as we'll shift this decimal from here to the right after the first decimal. Okay, so we have 18 0, then a number 1, that's the 19th digit, so this will be 1.6 into 10 raised to power, we have 18 zeros and we have one more digit which is 1, so it will be minus 19. Okay, after shifting the decimal from here to here, okay, we have 18 zeros in between, then one digit 1, so it will be 10 raised to power minus 19 column. Okay, so let's see the next one now. We have size of a bacteria is, let's write size of bacteria is equals to, we have 0 point, let's count the number of zeros, we have 1 2 3 4 5 6 and 5 meter. Okay, 1 2 3 4 5 6 5 meter. Okay, so this will be 0 0.1 2 3 4 5 6 and 5 meter, as shifting the decimal from here to right after here, so it will be, we have 5 zeros and then a digit 5, so it will be 5.0, you can just write 5, okay, into 10 raised to power minus 7 meter. Okay, so we have the 6 zeros and the 7th is the digit itself, which is 5, so it will be 10 raised to power minus 7 meter. Next one, size of a plant cell. Size of a plant cell is equals to, let's count the number of zeros, we have 1 2 3 4, then 1 2 7 5, okay, 0 0.1234125 meter. Okay, this can be written as 0.01234125 meter equals to, we're going to shift the decimal from here to right after the first digit, so we have 4 zeros and one more digit, that is 1.25275 into 10 raised to power minus 5 meter. Okay, so that's the answer for the fourth one. Let's see the fifth one. We have thickness of a paper, which is 0.07 mm. Okay, thickness of paper, it is 0.07 millimeter. Okay, 0.07 millimeter, or we can write this as 0.7, not 7, 0.07 millimeter, as shifting the decimal here, that means we are moving only two places, so this will be 7 into 10 raised to power minus 2 millimeter. Okay, so that's the answer for the part 5 of question number 3. Okay, I hope you understood. What we did here is we have written the number in the standard form. Okay, question number 4 is, in a stack there are 5 books, each of thickness 20 mm. Okay, so we have 5 books, each thickness of each book is 20 mm, and 5 paper sheets, each of thickness 0.16 mm. What's the total thickness of the stack? Okay, so let's start with answer number 4. We are given the thickness of one book as 20 mm. Okay, thickness of one book is equals to 20 mm. So thickness of 5 books will be 5 into 20 mm, that is 5 into 20 is 100 mm. Okay, then we are given 5 sheet of paper, each of thickness 0.016 mm. Okay, so let's write, and thickness of one sheet of paper is 0.016 mm. Okay, so thickness of 5 sheet of paper will be 5 into 0.016 mm, that is equals to 0.08 mm. Okay, 16 into 5 is 80. So the total thickness of the stack will be, hence the total thickness of stack will be equals to 100 mm plus 0.08 mm. So that will be 100.08 mm. Okay, so that's the answer of the this question. We can write this in the standard form, that is 1.0008 shifted the decimal two places toward the left. So this will be 10 raised to power minus, not minus, plus 2. Okay, we're writing the bigger number to the smaller form, that is decimal will be positive. We are shifting from right to left. Okay, that means it will be 1.0008 into 10 raised to power 2 millimeter. Okay, so that's the answer of the question number 4 of exercise 12.2. With this we have completed all the question of exercise 12.2 and also completed the chapter 12. Okay, now we have to practice all these questions multiple times so that you understand them better. Okay, so that's all.